Okay, my friends, this is going to be a treat, especially for me. This is the new Teacher of the Year, National Teacher of the Year. She is a calculus wizard. That's what I need to prove my electron flood theory. I'm going to show you what it is, and it is the new standard model of physics. If as a teacher could prove that or disprove it, I think that would be a pretty powerful teacher. Let's see if she can do one or the other. Okay, my friends, this is atomcentral.com, and my allegation is that the white particles will come up to here and burn this house up, just burn it, not move it, and then the black particles come and knock it from behind. And what am I referring to? I'm referring to this event right here. That's the explosion. The white particles are being pushed by the black particles. The white particles have no mass to them, but they burn. The black have a mass, and they push and don't burn. Then everything will return to its source because all of the gravity has left here. The black is the gravity. It'll all come back. Now let's watch it actually happen. Here it goes. This is, again, Atom Central. Now, I got to run on slow. It's in slow motion. The first thing we're going to see is a brilliant white glow, and every particle in the air and everything combustible will start to glow and burn. The house didn't move. It didn't move at all. And anything that hit it head on, not the sides, you see, now it's all burnt up, basically. All the things that can combust. Now, there it goes. Now it'll turn around and come back. Why would it do that? You see it coming back? It's coming back because I believe it wants to pull itself back for gravity purpose. Okay, my outstanding friends. So why would I be dragging her into into my physics stuff? Well, she does calculus. Calculus is dedicated to change, is to calculating the different change that happens based on different things. And I'm going to go through this is the research I'm doing on elementary particles and protons and electrons, neutrinos, all that stuff. That's why I want her to do the calculations. Is my physical evidence supported by her calculations? And I'm a physical material guy. I'm going to show you all this in so much detail. If you have a problem, I want to know why. Here we go. Okay, my friends, get anybody that is interested in physics whatsoever to watch this, because I'm going to show you right now. The new physics is here right now, and I can prove it. Let's go with neutrinos, which are elementary particles. They're the tiniest particles that exist. Everything is made of them. They're elementary. That means nothing is smaller. Now, a neutrino has different flavors. You see what happens here? Neutrinos oscillate. That means they go back and forth between different flavors in flight, which means different flavors means different masses. There's three masses all incorporated in the same particles, and they just can't figure out how come they change. They relate it to ice cream. It's like you go to the store and you buy a neutrino ice cream, and it's vanilla. And on the way home, all of a sudden you look at it and it's chocolate. And then a little later you look at it and it's strawberry. And by the time you get home, it's tutti frutti or something. It just changes, and they have no idea why. I am going to show you the change, and I'm going to explain exactly why. And we want to use calculus to figure out if the mathematical model fits the observed. Now, as I showed you before, or will show you, the new Teacher of the Year nationally is a calculus wizard. Now, nothing could be more interesting, I would think, to a calculus wizard than to calculate the change of these energies based on these basic presumptions. And I have all the, well, here it is right here. Teacher of the Year, calculus applied. That's what we want to do. We want to change the atomic standard model. Well, I do anyway. The new model is going to be called Dipole Electron Flood, which means that's all there is. There's two elementary particles. There's a muon and electron neutrino, the muon neutrino, electron neutrino. And I've got all the variables here and the values of them and how much they weigh and how many dipoles are in a proton and in a neutron. And according to these numbers, they should show something similar to what's going on here. Now, I'm going to explain to you, this is physics of light, which is all the particles there is consist of the particles that make up light. That's all there is. Everything is made of the particles that make up light. I will show you, and those are the particles right there. Okay, this is based on light research that I did with Rod Warren from Australia 5-6 years ago, and these are the actual photographs, the pictures that were taken using CMOS, which is in cell phones. And they discovered this back in 2014. I think this was started about 2015, somewhere around there. This is pulsed red laser from a construction laser. Bim, 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 bim. And you see all these little white dots in the air. What's that all about? Those are gas molecules. And they have magnetic fields too. Everything has a magnetic field. When you push to it, it expands and it glows. That's what light is. They're making these things glow to get out of the way. Now, that's before it is accelerated. It's just beginning to accelerate here. Here is the full acceleration. All right, so let's look at this a little closer. Here's just starting to accelerate, and the particles of light are in here. There's a ton of them. There's not just one. And all of a sudden, it senses this venturi, which is right here. Now, a venturi is a restriction, and what happens is it goes just like this and just like this. And all of these fields, which are now big, they have to crush down to get through this venturi, and they just explode. It's nothing different than hitting head-on, because we're forcing them to go sideways. Exactly identical to hitting head-on, only we don't miss. They have to go in, and they just pinch them, boom, and then they just explode. Now, here is a variable right here, the width of the venturi. The other variable is what the material is made of. How hard is it going to hit these sides? Is it going to go in softly? Can it roll away into here? Is it going to be, there's a lot to this venturi, but we just got lucky. Rod actually was the one that got lucky. He used two nails, literally nails, one right here and one right here, trying to create a little slit, and he did. And it was so tight that only the white could get through, no black whatsoever. There's not a single taste of black got through here, none, zero. And when I saw this, I flipped out. And he worked with me for several years, and then he sort of went blank. I haven't heard from Rod in years now, so I don't know. I hope he's all right. But anyway, I'm just going to go forward. Now, what happened right at this venturi? Here, it started to accelerate. And it got brighter and brighter and brighter. And all of a sudden, you see it's white, glowing white. Well, that's this right here. And I have more shots of this. This shows the neutrinos being developed. And that's what happens as it moves. The particle back here isn't glowing, it's glow, 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 boom, an explosion. That's what the flavors are. Blue is just a rocket ship. These are the Higgs fields that come back together over here. This is fusion. This is fission. They break apart, the black and the white, no question whatsoever, they break apart, which I will show you, absolutely zero question. And they come back together here. That's fusion, so it's fission and fusion. In the subatomic range, which is in the inside of a proton. Normally, atomic bombs, you're outside the proton, you're breaking up big chunks of particles. Well, you're breaking up protons too, a lot of protons, but it's not the same as this. We're starting with this particle here, so we can't break big chunks out of it. We're making smaller parts of it. Smaller parts is nothing more than light. Nothing more than light. So if we can harvest this as actual electricity, because that light is electricity. Solar panels make electricity. You have to be an idiot not to understand this. I'm sorry, I got to chill out for a minute. It's unbelievable that this is not being looked at. Now, anyway, hold on. Okay, this is Fermilab's article on what's the point. You have point particles, which is this one here, and you have an extended particle, which is this one here. The black one never changes. I showed you that. That's never going to change, and I will show you in so much detail there's no denying it. And the white or red or green or blue, they can get big, they can get small. Again, no denying this. I will show you this. Now, this is kind of cute. I'm sure you've heard of the observer effect. When you look at something, it changes what the thing is. Well, it doesn't. You're adding energy. Listen to this. If you magnify an extended particle, it will look bigger. That's the black one. You focus in on it, it'll just look bigger. Everything's fine. A point-like particle will not change in size, but the more closely you look at it, the stronger the field surrounding it becomes. This is the point-like one. So if you're just looking at it from way back here, it's no big deal. But if you get right down close, look at it, it glows. Well, you can't get down close with your eyeball. You have to send more energy in there to get more energy back out. What you're doing is expanding the field. That's all it is. You're pushing energy in and watching it come back at you. This is a bouncer. This bounces light back at you. It's a bounce. This one sucks up light. It wants light just to hold around to it. That's gravity, that's dark matter, that's the muon. Okay, here's another one from Don Lincoln from Fermilab. This is back to 2013. Empty space isn't empty. No, it's not. It's filled with the particles, and he says it right here. It says it's a dizzying display of change. Empty space experiences similar activity as a root beer bubbling, atomic particles winking in and out of existence. These ephemeral subatomic particles are real and have a measurable amount impact on our universe. Absolutely. They're particles, they're there, they're real, they fill space. Quantum foam is real. Microcosm is in continual motion everywhere out there. The only time you see it is when it gets banged into. That's why they blink on and off. It says the universe is not only stranger than we imagine, it's stranger than we can imagine. That's the problem. And that's what I ran into with Don Lincoln. He couldn't accept what I was showing. He refuses to engage. So, and this goes back 6 years or so that I've been trying to get this to be seen. And I'm showing the particles they're looking for, but I'm using light, which they wanted to use back in 1978. They had a special commission on it, and they couldn't figure out how to do it. All you got to do is put it through a Venturi. This is the key. It says, in summary, extended particles, which is the black one, have a fixed size. I will show you, again, in so much detail, undeniable. They may have a fuzzy edge, which is the color, basically, around the black core. The point-like particles are mathematical abstractions with zero size. When they're sitting unperturbed, they may have almost nothing. I can't believe they have a zero size, but let's just move past that. They say even a zero-size particle can have an extended effect due to the effect of the field surrounding them. Well, it's got to be surrounding what? If there's nothing there, there's no surrounding anything, there's nothing. So there's got to be something in that core that is attached to that black particle. Let's take a look at the experiments. Okay, my friends, so where are we? This was Fermilab. Let's take a look again. Remember I showed you Don Lincoln at Fermilab showed the fixed particle and the point particle. And that's what we have right here. And this is the photon phase. This is when it's a full-fledged photon. Prior to this, we have neutrinos, different flavors, as it's building this photon value. These are the dark particles, the fixed particle right here, and they have a glowy edge around them. I mean, there's absolutely no difference whatsoever to what they're showing. Only here's what happens at Fermilab. In order for them to break these particles and see these two particles separated, they have to create a bunch of garbage. We actually do it much more cleanly. Here's what they do. They take two gigantic particles, I mean actually billions of times bigger than ours, and they hit them head on. And then phew, everything goes. Well, why is all this red staying kind of close? I can tell you why. It doesn't have much energy. It doesn't have enough energy to get away. Why are these reds, I mean greens and blues and yellows, all coming streaming out of here, and these white little flick, flick, tick, 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 just the white ones coming out? Why? I can show you why. It's because they have all the energy right down tight at the inside core. The nucleus is held this whole stuff tighter than hell. As you get out further, you get out to the red way out there, but you start with the white and blue right in tight, and then it gets bigger, 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 and then you get loosened and they just fall right back in again. So, you know, these are not energetic. Everybody knows the red shift. Red means less energy. Okay, let's just go right to the heart of the matter. Neutrino flavors. This is Fermilab again. And they're saying perhaps the most important thing that you should know about neutrinos is that they come in three types, or what they call flavors. Electron neutrino, muon neutrino, and tau neutrino. Now, neutrinos are strange particles. Scientists were quite surprised to find that the flavor of a neutrino changes as it travels. The same neutrino can be any one of these, they say. How is that possible? It's not the same neutrino. They see it in an energetic value that's based on its interaction with what it's passing through, as I show very clearly. All right, this research was done basically with these. That's it. You should get a kind of glasses, and each one of them, each different frequency has a certain type of glass you should use to protect your eyes if you're going to do this. But this was it. This was it. This is what Rod used. A Bosch GLM-15, which is a construction laser, and all he did was take the selfie side of this Samsung GLS-3, and he was taking pictures all around as it came through. And then he would sort through it. You know, I mean, he must have spent hours now. I played around with it. I did some, but nothing like his. So what you're going to see is all from Rod Warren from Australia. Now, this is the same particle. They take, and you know, because it's light, you're catching the same particle, and it changes. You see it here? That's a white and a black particle, but there's only two blacks and one white. This one has two whites and two blacks. This one has up sideways, and this one, but they're all the same particles. They're all light particles. Let me put it that way. As they come through the air, they sort of push everything out of the way. But when they accelerate like this, then you really get to see what you got. Otherwise, you can't see anything up there. Let me see if I can show you something, make it more obvious. Okay, I hope this will make it apparent as to what's happening here. This is the pulsed red laser, and it's coming through the air, and all of a sudden it's starting to deform its wave. It's being pulled out of here like squirted through a hose, and almost exactly what's the same situation. This is called a venturi. And all of a sudden these lights started stacking up on themselves right about here. See it? From here to here, it's changing its neutrino values. It's getting more and less energetic as it bumps into the other particles that are being pushed back. These are pushing back this way. You see this reverse electromagnetic field? This is what creates neutrinos. As they come through the air, they're getting banged back against. So they're going here at 100 miles an hour, and they get banged back against, they go down to 99. They get back up to 110 miles an hour, whatever it is, bang, and they go back down to 105. And they see them floating all over the place. Now, they say there's three flavors. There's many, 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 many other energetic levels in here. Dozens. Now, they can see the red, blue, and the green. Excuse me, as particles. And I do believe that that may be a consequence of the geometry of the particles that are able to emit light. which could be just the red, blue, and the green. But they're going to come back at you in so many different molecular formations. You're going to have yellows and oranges and purples and all kinds of things. Well, obviously, that's what you see. You see those particles all the time. I mean, that's what color is. I have a lot to display here, and I'm sort of getting lost at what I have shown you so far, but you can see that the green is virtually identical to the red. The green is a little harder to control. This side is completely devoid of the black, 100% white. This side has the black in with it. And that's coming at us through the Venturi, and we're seeing it here but not here because it's like a little offset somehow. She's hitting this side a little harder. I don't know. It's got something to do with the way the Venturi is. There's a lot to think about here. This is no 5-minute job. This was years and years and years of research. Now, these are being concussed. These are also particle waves. You see it? Same thing. Here they are here. They're particles. Now, I don't know if they were waves originally or they're just particles that are being concussed backwards, that are just hanging around in the air. I don't know. But I'm going to tell you what, that's the same wave, only it's being pushed this way instead of this way. This one's glowing because it's going this way. These are glowing because of the reverse bash against it, which you see it way back out here. I mean, that is a powerful, 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 powerful reverse electromotive force. Electromotive force means magnetism against magnetism, basically. And it moves things. And all these little tiny particles in the air, you see them? I don't know if you can see those clearly. You see how they're all little glowy particles? Every one of those is a gas that has an electron attached to it. And the electrons glow. The black part don't glow. So what have we seen here? We're seeing light accelerating like hell. Pew! And concussing, creating these different energy values, which are the neutrino values, and then creating sterile muons, which is the black all by itself, and the electron showers all by themselves. So that's a split from the black and the white coming back together here right at this approximate zone. Now, they will jump right back in wherever they can if there's not so much energy as there, the white ones just explode. Now, I have another shot that's absolutely stunning. Don't forget, let's look at this real close. I've got a real close shot of that. Where is it here? All right, there it is. Boom. It came in and you saw it accelerated, and right here, there's nothing. It's just white, 100% zero blackness there. Now, what happened here? All the black ones started to come back together. They want to be attached. And they're jumping right in on these, what they call interference patterns. They're not interference patterns, they're spin patterns. And I'll show you the light spins. And they're jumping in just as fast as they can when that white sort of settles down. Boom, they jump right in. All around the edges, they'll jump in. Here, it can't get in. It's just too much brilliance. Now, this is another one of these socks removers. I mean, it blew my socks off. Here you have nothing but white. And then the black attaches right at this. This is losing energy because it's reconcussing with atmosphere that is keeping the energy value a little bit lower, and then they start to recombine, and then it becomes back to background level. Now, wait till you see this. Watch this. I told you the black pushes the white. This time, Rod let a little tiny bit of black get through here, instead of no black whatsoever. Look at this. Don't forget now, I've said it 100 times, and they say the same thing at Fermilab. The black does not change size. Never changes its size. But it pushes the white, and the white can go big or it can go small. This is the leading edge of literally a subatomic explosion. This is the nuclear center of the explosion. Out it comes with the black and the white particles. This time, the black pushes the white, and these are all ripple effects because it's boop, 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 and everybody's got to get out of the way. See how close these are? How far away these are? That's the effect we're getting here, because the white absorbs. That's a little hard to explain, but anyway, the white is going to just fluff up, and I'm going to show you the atomic bomb blast. The house will be here, and it'll just burn right up, but it won't move until it hits the black. Then the black bounces it away, and then everything turns around and comes back because of the vacancy. Isn't that something? That black, you'd never see that black pushing that white like that. That's the first time I ever saw that. Okay, like I say, I got a little confused after a while here, but I showed you the light accelerating. There's no question whatsoever that's acceleration. I mean, if you can describe it any other way, I'd like to hear your explanation. Now, I have shown you that the black pushes the white. That's pretty obvious. I've shown you that they completely separate depending upon the way the Venturi is configured. This is the key. All of this stuff has to be configured correctly to do these different things. And this was just by accident. Really, I've got to be honest with you, it was by accident. And this is where it divides the green going this way. I mean, the black parts of the green going that way, and the white parts of the green going the other way. This is the whole batch of them. This is the neutrino values changing as it comes forward until they create fission. This is in outer space. The Russians did this in outer space with charged particles in a vacuum chamber in basically zero gravity. And this is what happened. All the dark particles went right to the center and the white ones collected around it. Exactly what I would expect in electron flood theory. They were blown away. One guy locked himself in his office for 3 weeks. He freaked out. And they still don't know what to make of it. Oh, I talked to you about light spinning. Here it is right here. If you talk to any machinist, they'll say that that's a drill bit. And that's spinning particles. When they spin through there, the white ones say, get away, you 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 get away. And that's why you have these interference patterns. That's push to shove, push to shove, push to shove. And they create these lines. In the center, they're spinning over here, spinning over here, spinning over here. So in the center, you get most of the hits. Because it can go this way, or it can go this way. And that's what you're getting, this way and this way. All right, so that's the spinning particle. I think that's something new that I didn't show before. This is the blue, which is just, it comes through here. You can't even tell it's got 2 whites. By the time you get out to here, you can barely see that the whites are starting to separate, and the frequency is expanding. This is accelerated light. It's accelerated, and this is slowing down over here. I know it looks almost like the opposite, but it's stretching out. The red shift is a stretching effect, and that's really, this is a blue red shift. And again, this is point particle from Fermilab. It's the same particles, no question. And you can see this one glowing and that one not glowing. Well, it's glowing less. And when this charges up so much, as it hits these particles in the front, this will charge up and get really bright, and then it'll flip. And I can show you that actually occurring with the green, because the green is the same particle. See it right there? There's no difference whatsoever, same particle. And these are the neutrino values here coming in. They're a little hotter, hard to see. But then here it is right here getting ready to flip. The bottom part is charging here, and it's getting so charged up that it's going to flip in a second. That's my interpretation of that. Where do we go from here? Oh yeah, this is both particles coming through at the same time through the same Venturi. You see the red very dim. The green very, very powerful. See how bright it is? And when it comes through, it even turns itself a little bluish. The red just falls apart. And the green is so powerful that it reconcusses way out here, and it spins the red this way. They don't do that. They spin this way according to the Earth. This is spinning against the Earth's rotation. And they don't work that way. They're magnetic particles. They go along to the Earth. Not supposed to spin in circles this way. But they're interacting with their fields. Instead of spinning along this way, they force it to roll. They're making it roll. Rolling, rolling, rolling. Keep them doggies rolling. Rawhide. And here's your rawhide right there. What is this? Higgs fields. Oh, how'd they get there? This thing right here This white stream is 100% electron showers. There's no black in there at all. None. Zero. Well, I can see there might be one or two in there, but not many. And when they hit the rest of the world, they start to spin into these Higgs fields. They know this. This is no mystery. But ours are good ones. The ones they got from CERN are like this, and from Fermilab, they're just debris, because they're hitting head on big, huge particles, just spinning all over. And they got these red particles away on the outside, so they don't go far. The ones real close to the core, pew, pew, pew. So they see everything we see, only we see it for much less money. Okay, I think I've made it pretty clear that the only particles that exist is the W boson and the Z boson. The W is the white one, the Z is the black one. These two together make a gluon. That's the black and white particle. Just one of them is really an electron. They just never knew the black part was attached to the white part. So consider a gluon and an electron. Consider that the muon. And consider this the electron neutrino. So electron neutrino plus the muon neutrino make a gluon, which is really an electron. Two electrons back to back like bar magnets make a photon. That's it. All these others are flavor particles of the impact values, strange and down and bottom and charm and all these. They're only values of this. Now, the Higgs is that particle I showed you with all those circles. The Higgs is really when these two particles come together. When they separate, they have to come back together. They will always come back together. When they do, they create a Higgs. We focused ours so violently to make Higgs that we show them up in just scads and scads. But what we did was we changed we divided the white and the black. Here it is right here. That's just the white. When it hits all of the stuff in the air or wherever, out here in the atmosphere, the Higgs just pop right up. So there's got to be a ton of extra black particles just laying around. You see how fast they jump in here? That's what we're seeing here. These Higgs fields are these fields coming at us. And they do it in the green, they do it in the blue, and they do it in the red. And they probably do it in a lot of other colors too. So that's what we need to do, is look into neutrinos. And then if we could harvest this energy right here, that's energy that's just off the charts. That's my feeling. I could be totally wrong, but I just saw somebody today. As a matter of fact, let me see if I can find it. He's offering like $20 million to somebody or to people, giving $100,000 here, $100,000 there. I don't need any money. I don't want any money. I want somebody to do this research that has the facilities and has the ambition and drive. I'm just starting to lose it. I'm telling you, I got to be honest with you. It's been many, many, many years and many, many, many topics and many, many, many refusals. So somebody else is going to have to do this. Now, all this research was done for a few $100s. And this is just nothing more than this laser right here shooting through these nails, which are here. I don't know how far you'd want to be away. Again, Rod did all this. And it was just an accident. So that Venturi forces everything to come together. And they say it should increase the energetic value 200 times at least. And I don't see any reason to not agree with that. Again, the photons and muons and electrons, and the electron part is coming out of here. An electron means electricity. We could send it through a photodiode, which means it can go one way and it can't come back out. So we go bam, 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 and it goes doo, 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 and it gets locked down in here in the batteries. It can't come back. Cannot come back because you've got a diode, one way only. Then you take a little bit of this and you keep the laser going, and the rest you use for whatever you want to use it for. And you never have to stop this. This continues continuously, 24 hours, 7 days a week. And we're only using light, so it's not dangerous. We're not polluting. We're creating electricity that you could carry around. And I show this just, this is an old Geiger counter, but this, you could have any kind of outlet you want in here. Once you harvest this electricity, then you put in your little regulators and converters and all, whatever you want. AC, DC, 110, 220, 50 cycle, 60 cycle, USB, anything you want. You carry that around. That should power a house. This stuff, this is some serious energy if it works. If it doesn't, well, you just spend some more money. I'm not talking about a big investment here. I'm talking about a few $100. Now don't forget, Rod used the selfie side, and that's probably got more pixels. And apparently he was just going right down here. You go right into it, boom, shooting it right into there, all the way around it. And he had so many. I mean, I literally had thousands and thousands of pictures of different things. And then we ferreted through them, and I said, "Can you do this? Can you try that? Can you move this? Can you?" And he just kept trying. But nobody. And I figured for sure it would pay off. Not to pay off for like money or anything, but that somebody would take an interest in this. Maybe we could save the damn planet. But that never happened. And it's strictly because the people that are in power want to stay in power. They don't really care about the honesty. That's what I'm finding. It's a terrible thing to say, but I say what is true. I don't want to say something that isn't true, and that is true. It's exactly what I found. In the last 10 years or more, there's been no interest whatsoever from things that cannot be denied. Absolutely can't be denied. And DNA tests and CAT scans and specimens of all my mudfossil research. They deny my buddy Caesar right here. He's a goose. He has his feathers. They denied all this stuff until Yale wrote their own paper saying there was a worldwide flood that preserved all of these creatures in perfect preservation, which is what I tried to present to them many years before. And then they took credit for it. A year after I finally wrote the book saying, this is crazy, da-da-da-da, then they put the paper out that, yep, it happened. And they apparently they didn't give me any credit for it. So, and this is, and I guarantee you, I've tried to contact, I contacted Don Lincoln. We went back and forth many times. And he just finally just said, don't ever contact us again. Never took one interest. Nothing but you're wrong. Don't ever contact us again. Okay, my friends, I am going to show you almost this exact same event. This is the nuclear blast going off. It's subatomic. We're not throwing out hand grenades. We're just sending out light. But we're sending it out so violently that the black just pushes the white ahead. The white is a burner. The black is just a pusher. What we're going to see is a house that gets hit by the burner. Doesn't move, just smoke comes out of it and everything burns up. And then comes the black and it just pushes it. And then everything goes back because you have a vacuum here. And I believe it's a reverse gravity effect. The black is the gravity. We just blew it all away. It has to come back. So don't forget now, the house is right here. It's coming at the house. The house will just smoke up like crazy. Everything around it that's combustible smokes up. And then, boom, it goes flying, and then, whoop, it goes back. Here it comes. All right, here it is right here, atomcentral.com. And they're going to show the atomic bomb blast. You can see everything just smoke up and burn, but not go moving anywhere. And then it'll all go flying when the black comes. So here it gets ready. Boom, there's the white. That's all that's happening. It's just boom, then that comes. All right, let's slow it down and look at it again. All right, we're going to come down to 25%. Now, watch what happens here. The first thing that happens is just it smokes up. Anything combustible is so infused with the white particles that they cannot handle it. That's the burners. They're in their same fields, and zoom. Then comes the black ones, and it's just going to go, everything goes flying. That's the sound because it's running at such a slow speed here. And then everything comes back, just as I precisely said. One more time, here it comes. The first thing is we always see is brilliant white. Everything glows. That's all the gases and everything. They've all been done. Now the stuff that is absorbed, it starts to just smoke. Now everything goes. Now everything turns around and comes back. I believe there's gravity back there because the black is gone. But black is gravity.